For this video, we're going to discuss places where the slope of the tangent line will not exist. And the first of these examples is going to be what's called a vertical tangent line. And we just saw one in our previous example with our square root function. If we draw the square root function and we look at the origin, which is defined at 0, 0, we'll notice that it is impossible to have a slope of a tangent line here because the slope of any vertical line is undefined. So the first case we look at is a vertical tangent line. And again, there is no slope in that case. The next example we're going to take a look at is what's called a corner. And the common functions that have these are our absolute value functions. And you will notice that it is impossible to prescribe a slope of a tangent line here because there's just an infinite number of possibilities. And again, we wouldn't know how to prescribe a function value there. So again, that location is referred to as a corner on a graph. The next one we're going to take a look at is called a cusp. And these are usually formed with radical functions that have fraction exponents that have an even and an odd as part of their fraction. So a good example would be, for example, I think the 4/3 power would be a good example of such. But again, those have a graph like this. And in that case, we see ourselves having an infinite slope. Kind of missed the mark there on that one. But we see ourselves having an infinite slope where on one side of the slope of the tangent line, you're looking at a very large positive slope going in this direction here. And here in this direction, it's a very large negative slope. So again, those are called cusps in a graph. And we see a lot of those in our cube roots, squared, fifth roots, squared, and so on. And the last example is going to be where we see just a discontinuity in general, such as a jump discontinuity. In this case, it is impossible to prescribe a slope of a tangent line, and this is similar to the second example where there is just an infinite number of possibilities of describing the slope of that tangent line. So this is basically just a discontinuity in general. So you see that functions have to be continuous if there is any hope of having a slope of a tangent line. But even in that case, it may not have a slope of a tangent line, as we saw in the corner and the cusp and our vertical tangents as well.